So you notice in the first pair where we stretched it vertically, then stretched it horizontally, or stretched it horizontally first and stretched it vertically second, we end up with the same coordinates after both stretches. So in this case, although it's not comprehensive, we can see that in this case, if I stretch it one way and then stretch it the other way, I end up, and the order is not important upon which way I do that. However, the next two pairs, we reflect and then translate, or reflect then move. Okay. We end up with -4, 2, 0, 4, 2, 0, 4, 0. We do not end up with the exact same thing down here when we do it in the reverse order. We end up with -4, 6, 0, 8, 2, -4, 4, -4. So that means if I want to do it a specific way, and I want everybody to get it the same way, I have to have a specific order. Whether it's move, then reflect, or reflect, then move. Now, in this case, I'm going to pick it up, move it, and then I'm going to flip it. And in this case, we were reflecting and moving in the same thing. We were moving it up, down, and then we were reflecting it up, down. Okay? And our third pair, we reflect and then move. Okay, yeah, that's my third. So here we reflected in the y-axis this way and move it that way also. We end up with different points on the graph in both cases. Okay? So the reflection, which pairs don't give you the same answer? We talked about stretching in one axis, then the other axis. If you have a move, which we did in all those cases, we reflected vertically and then moved it vertically, or moved it vertically, then reflected. They gave you two different things. So there has to be some type of order that we have to take a look at to get the graph that we want from the equation. So there is a restriction when we want to deal with equations. Right? So here we have a generalization that I want to talk about. Here we have 4 different transformations from this equation here. The order that I need you to do this in, I always say alphabetical order. I don't care about the first two. Translate has to come last. Okay. If I stretch something and then reflect it, I'm going to get the same thing if I reflect it and then stretch it. So that's why the order of R and S, reflect and stretch, are not important. Okay. So we have 4 transformations that we have to deal with here. We have a vertical stretch by 2. In the x-axis. We have a horizontal stretch by 1/3 on the y-axis. And I don't care which one of those happens first. It's not important, because they're independent of each other. Where we're not independent is we have move to the left, 6 up. This here has to be at the end of any transformation. Do your stretches, your reflections in any order. Their multiplication, order doesn't matter in those cases, but adding and subtracting does matter. Adding and subtracting always comes after multiplication in BEDMAS. Same principle here. Okay, so order. We have 4. We have a move. I'm going to leave it alone. Taryn, what is the horizontal stretch in this case? Horizontal stretch by 2 in y. Oh, I meant to put y is equal to 0, and then I went axis. In the x-axis, that guy there, that's a vertical stretch by 2 d. Oopsie, I messed up. My axis is wrong. This is the y-axis, and this is the x-axis. Habit of doing things, making mistakes like that. And then it's the easy move part for us. Move 3 right, 2 up. Now, I'm actually doing A and B at the same time. The order that, a possible order is 1, 2, 3. A second possible order is 1, 2, 3. I don't care what you do first. What I care about is what you do last. So that's your answer down here in B. With this one here, I encourage you to get into the habit of doing this just directly from that. Okay? But we can manipulate this. I'm going to multiply both sides by 1/2. And then I'm going to subtract 3 from both sides. And then it just looks like an exact same process that we used on the last one. It gives us our verticals up and down without having to worry about changing things. So we have 4 transformations again, 2 moves, 2 stretches. We have a vertical stretch by 1/2. We have a horizontal stretch by 1/2. And move 4 left, 3 down. Again, the order that it must happen is that guy must occur third. I can flip, I can stretch, I can reflect, whatever, but I have to move left. Because if I move first and apply a stretch that corresponds to that move, like a horizontal stretch when I horizontally moved it, I don't have the same points anymore. That's if you're reading off of an equation like this. If the question says we do this, 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 and this, then you do this, 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 and this. And you're not going to get the same equation as if you would apply them in that order, or in the order that I'm saying here. So if I say move first, then reflect by 30, that's going to affect the equation. And I'll show you that, I think, tomorrow. So here is where we do this. Here are our 2 functions. We have 3 transformations. I'm going to do my vertical stretch then my horizontal stretch, and then my move. So, -4, -4, -1, 2, 0, 8, 3, 2. Vertically stretched, horizontally stretched, -8, -4, -2, 2, 0, 8, and where am I? 6, 4. Nope, 6, 2. So again, applying my stretches, and then I'm going to move. I'm going to move in one step. I can't remember what I moved it. 3 right and 2 up. So this would be -5, -2. This would be 1, 4. I got that right. 3 right, 2 up. 3, 10, and 9, 5. Nope, 9, 4. Now those would be the points that I would plot on the graph. -5, -2, 1, 4, 3, I'll say that's 10, and 9, 4. The shape is similar. Again, this is that process I talked about during pulse today. So we vertically stretched by a half, -4, -1, -1, half, 0, 2, 3, a half. Horizontally stretched by a half, now it's -2, -1, -0.5, 0.5, 0, 2, and 1.5, 0.5. I'm using decimals even though I like fractions, but in that case, decimals. And then we went 4 left and 3 down. -6, -4, -4.5, -2.5, -4, -1, -2.5, and -2.5 again. Now, unfortunately, I'm going to run out of room because I'm going to plot it into my graph or my coordinate points, but still going to be the same shape because I didn't reflect it. I didn't flip it at all. -6, -4, -4.5, -2.5, there, -4, -1, and -2.5 and 2.5. A little hard to see because of my plot, but for me, yes, sometimes I will do this without my points, and I make mistakes. And I've been doing this particular part of the course for 20 years. So the coordinate point system, if you're asked to sketch, or if you're asked to match Okay? Which of these graphs matches this equation? That's another thing that might show up. Okay. Now here, I'm going to ask you to do this in the order that it happens. I want to replace x with 2/3 x, replace y with -3y, and x with x plus 2. Doing this in order that they're giving to me. So I'm going to start with the function y is equal to f of x. It's going to become y is equal to f of 2/3 x. Then it's going to become -3y is equal to f of 2/3 x. And then I'm going to take the x in this statement and replace it with x plus 2. The -3y stays the same, f of 2/3, and I'm going to replace the x, so I need to put a bracket here. Yeah, finish my bracket off again. From here, now we can do the exact same thing with the x cubed. I'm going to work down to b. Well, we can do the order, which I'm going to, or I can just replace it here. Start with y is equal to x cubed. Y is equal to 2/3 x cubed. -3y is equal to 2/3 x all cubed. And then finally, we're going to replace that x with x plus 2. And my cube is outside of that function. So we can start with a generic function, as I did here, or we can start with a specific function there. And then you could tidy that up if you wanted. Y is equal to -1/3. I'm going to leave this in factored form all the time, because now I can read what we are going to do here. Vertical reflection, vertical flip, vertical reflection, vertical stretch by 1/3, horizontal stretch by 3/2, the reciprocal of that, and then 2 to the left. Start with our generic function f of x, replace y with 1/2 y. Replace x with x minus 3. And then finally replace x with 3x. Now notice this does not look like that. This, I can read directly off and get the right answer. This, I can't. I can get 2 of the 3 things correct. Well, how would I make this look like this guy? Well, I can take out a common factor. I can take out a common factor of 3. That's going to leave me with x minus 1. Now, what that shows me, okay, if I move something to the left 3 and then stretch it by 1/3, which is that 3 telling me, every point that's being moved is going to be 3 times closer to the y-axis. So this is something that we can use. This, I gotta fix first. This was determined by doing it in a different order. And then we would do the same thing. I'm not even gonna bother with this. 1/2 y is equal to 3x minus 3 cubed. So my function is the cube part. What I'm doing with this is pointing out that this here, if it's in that form, we've got to do something with it. You have to write it into the factored form. As I said, you could give me the process. If I just gave you this function here, you give me the right process. I've done this, this, and this. I do this. If you don't have it in factored form, you give me the stretches correct, but you don't give me the move. You don't get this from this equation, right? We don't get the order. So what we want to do is what do we do if we do the stretches first and then the move afterwards? And that's where we get this from. And we'll talk more about that tomorrow. So are there any questions on this? Yes, everybody go get your textbooks. The textbook is page 40, 7, 8, and 7, 6, 7, and 8. And then attached to your sheet, there should be workbook questions for you to work on for homework. Yeah.
So it should be like 0.1. Function
This is actually reflected.
Yes. No, that's like
Move it down.
Yeah, all I'm telling you. So you just want to move it left 4 down 5. Your original graph starts. Translate for the. So number 4, I remember the white one was I remember you right. So we went. And 4, 7, 8, 3. Oh, yes. Vertical reflection. So if we start with our point, we get 3, we get 2, 1, 2, 0, 1, 2, 1, and 4. So stretch by half, make it 145. Oh, I think it's fine. Yeah, that's what. It's the horizontal, so it's 0.5, 0, 1, 1. Okay, I say I gave. No, I swear. So that's why I think it's a good idea to write down what you thought and then figure it out.
Your invariant point was right for what you did.
For 7, I realize there its own. Independent is backward. So it's negative at forward. After collecting the y axis, negative x. And the first by factor of 1/4 is 1/4. Because this is exactly what I'm doing in my work. Okay, so it's like over here, on the opposite here. Because it's mapping notation, correct? It's mapping notation, it's exactly what happens. In this case, my x coordinate is 1.5. So my mapping notation for this guy would be negative 1/2 x y. So the reciprocal is when it's in some function, because I have to do something to this before I do the rule. This is describing what actually happened at every point. Okay. And B, I realized that it's supposed to be the top here, and y minus 2 is wrong. Move it 3 into what's to the right. Every y dot or every x dot has to be larger by another interpretation of the mapping notation. And then that is going to happen without it. Okay. 8. Vertical reflection. Vertical reflection. Yeah, not y is 0 here. Vertical reflection. It's going to be this way. Okay, 0. So if this was for this one, this would be y. Okay. And then for 9, it would be 8. Because we went from here, so you started out, we'll call that 1, 2, and up here at 3. So we are going to stretch it by a factor of 3 horizontally, and so 1/3. And we stretch it vertically by a factor of 2. And that's outside. It is 1/2 y, 1/3 x. That. That's where that 1/2 is. Plus, it's kind of confusing because they're thinking kind of outside the mapping notation thing. So you got to look at two separate things. Mapping notation, what happens to the x, y coordinates? Function, what do I have to do to this thing inside the function to get that thing? So it needs to, if it's next to the variable in the function notation, then you're reciprocating. Right? If it's next to the function, that's 2. I bring it over to here, right, next to the function. Okay, now I need to take the reciprocal. It's next to the function. Right? Okay, I understand. So I have 2 left to right, I can't do that. But see correction where most of the correction. So yeah, no rewrite that. No rewrite conflict. Well, that's no rewrite. Oh, shoot, I forgot to hit.